Welcome again to this continuing series on Bergson and his holographic theory of mind. This will be part 15, the 5 E's here: embedded, embodied, inactive, extended, and expositors of Gibson. This all is one, I'll call, largest position involving treating the brain as indeed embodied, as mind as requiring action, or the inactive, extending into the environment, not just limited to the brain, in various construals of that. And all of this is wound into and very much part of expositors of Gibson, or another way to say it is Gibson is very much involved in this. In this all we see endemic problems as to how to treat the image, or the image of the external world. Embedded within it is always a time-scale fallacy in terms of their thinking. There's rather an eternal fog around representationalism and the role of representations. And there's rather an exceptional barrier to a theory of cognition involved, in my opinion, in this entire enchilada. So the problem. There is a largest position that holds in general something like this. To understand perception, we must deal with the full system of body and environment. It's inherently anti-representational. That is, there are no representations in the brain. And the image of the world arises somehow via body-environment interaction. Cognition now becomes, in this anti-representational stance, somewhat of a dilemma. For this entire position is forced to do cognition without representations. And the question is, how do you do this? For how do you now support, say, a Penrose-like operation as we've reviewed, where he does a proof visualizing stacking of three-sided cubes into ever greater, larger full cubes? Or Wertheimer, as we discussed extensively. For example, the child taking a cardboard parallelogram, rolling it into a cylinder and asking for her scissors to cut it so she can make it into a regular rectangle to compute the area. And any number of other dynamic transformations that Wertheimer described I discussed in part 13 in education. Or Piaget, with his rather large number of experiments, very large number of experiments, involving dynamic transformations of imagery, such as rotating a tunnel and determining which order the beads will come out. Again, I discussed all of this in parts 6, 7, and 13 on cognition, evolution, and education extensively. This is a major problem or foundational aspect of cognitive thought. But somehow we're supposed to deal with this without representations. So I'm going to go briefly through these 4 folks. Louise Barrett, in her book Beyond the Brain, How Body and Environment Shape Animal and Human Minds. Again, the emphasis on body and environment action in the body. Anthony Chemero, Radical Embodied Cognitive Science. Alvin Noé, Out of Our Heads. And Mark Rowlands, The New Science of Mind, From Extended Mind to Embodied Phenomenology. Now, I'm not going to be able to do justice to any of these, what I consider actually interesting and fine works. But I'm going to, of course, be picking out and grabbing the essential difficulty that they all face. So the pattern and the problem should be quickly clear. So we start with Louise Barrett, Beyond the Brain, How Body and Environment Shape Animal and Human Minds. So an important focus for Louise is the explication and clarification of the anti-representationalist stance of Gibson. She points out that Gibson's theory of perception indeed cast out representations, that is, any notion of a model of the internal world or little chunks of models or whatever inside the brain. And we've noted this before. But he fully allowed for them in imagination and memory. The difficulty, as we'll see, is that down the road in her book, she torpedoes this imagination and memory point and representations. It's quickly done away with. Arching over all is the theme that to understand perception, we must deal with the full system of body and environment. Now, as is common with the literature explicating Gibson, Barrett's explication of the key concept of direct perception in Gibson is an illusory one. Remembering direct perception is the notion that we see things right where they are, where they say they are in the external field. The coffee cup on the table is indeed being perceived as indeed out there. It is out there, and that's what we're perceiving directly, through no mediation, no representations within the brain. But the language she uses is self-convincing that the concept is understood and explained. She simply states that the brain and the body should be viewed as, quote, part of a loop with the environment. So the body and brain with the environment form a part of a loop, right, in the process of information pickup. This does not explain the origin of the image of the external world, no more so than a robot and its comparator system, as we've discussed before. Again, we have a loop in that comparator system where we take a snapshot of the external world, run it through a prediction generator, store irregularities, project another possible state, check it, act upon it, etc. We're in a loop. But a robot can be put in the same loop. And yet, we now have to allow that the robot is seeing the cup just because it's in this action loop. So let me take a few slides here again, and I apologize if people have been watching this series, but we'll go through it quickly, of what it means to embed Gibson within Bergson and why this has to be done, or you end up always with these rather extremely inadequate discussions of direct perception and what Gibson means. Remember, Bergson viewed the universal field as a vast interference pattern. Viewed as a sea of waves, for example, each point in the field is reflecting or carrying information for every other point, for the whole. So he saw it as a holographic field. This was his, to quote, photograph already taken, already developed in the very heart of things, and at all points in space that he noted in matter and memory. And we noted that David Bohm brought this whole concept out in 1980 in his book Wholeness and the Implicate Order, where he argued explicitly from the point of view of physics that the universe is indeed a holographic field. But Bergson had already gone there in 1896, which is why no one understood him. But the brain for Bergson is not simply a hologram as it was for Pribram. The brain is, or is creating, very concretely, a modulated reconstructive wave, and this wave is passing through the external holographic field. And this wave is specific to a key term, it's Gibson's term, or specifying a subset of the vast information in the field. That is, the wave is specific to a source within the field. And by this process, that source is now an image: the coffee cup, the table, and the stirring spoon. And as we talked about modulating the reconstructive wave, remember we can store a picture, say, of the cup with a certain frequency 3 here, and specify it when the reconstructive wave is passed through the hologram. But we could have stored a cube with frequency 1 and modulated the reconstructive wave to frequency 1, seen the cube. Or we could have stored with another reference wave a little wine glass, modulate the reconstructive wave to frequency 2 and see the wine glass. Go back to frequency 3 and see the cup. Or back to frequency 1 and see the cube. So this is what is meant by modulating the reconstructive wave. We're changing the frequency pattern, and we're looking here at the brain as a very complex frequency pattern passing through the holographic field and being specific to an aspect of that field. The field itself, the holographic field, is not imageable. So Bergson visualized the holofield, the holographic field, as a vast set of real actions, as he conceived it, rippling everywhere, where each object is affecting every other object. Each object is a focus of forces from all other objects, like the Mach principle. The subset of these actions are information that the brain-created reconstructive wave picks out or selects, because there's any amount of information that can be selected. This subset is that related to the body's action capabilities. That is, to grasp a coffee cup, or to pick up a spoon and stir the coffee, or to run across the surface, like our parrot there. Action relatability is the information selection principle from the holofield. Thus, Bergson stated, perception is virtual action. We are seeing how we can act. And this will be important when we relate this back to Gibson later on as our four folks discuss things. In fact, going there right now, virtual action relates directly to a fundamental concept of Gibson, namely that of affordances. For Gibson, too, we are seeing the world as related to our action. A surface is walk-onable, or run-aroundable, as the parrot there. A cup is graspable. A stairway is climbable. And the Gibsonians have worked at looking at mathematical ratios that help specify some of these things. For example, there's a little ratio called phi, which, as I recall, is the ratio of riser height to knee height. Remember, we're focused on relating the body to the external environment, the height of one's knee, which seems to indicate or specify whether a person perceives those stairs as climbable. As the riser height gets too high relative to the knee height, they're not climbable. So Gibson talked about, and the Gibsonians talk about, affordance structures. I tend to talk about invariant structures because it's a little more straightforward and easier to understand, but that's something we'll talk about down the road. But virtual action carries the implication of action related to time scales as well, as I've noted several times now. The buzzing fly is a buzzing fly only at normal scale. The brain, via its dynamics, its underlying chemical velocities, is specifying a time scale, or a scale of time upon the world, a buzzing fly. I could just as well have a heron-like fly. It's flying, flapping its wings very slowly. A slow enough heron, a virtual immobile heron, would specify a possibility of action, namely reaching out in that time scale and taking the fly out of the air by the wingtip. Action has to be, by virtual action principle, correlated precisely with perception to be ecologically valid. Else I suffer anomalies of action relative to perception. So in this holographic reconstructive wave model, where within the brain there are indeed no representations of the external world, we now have a concrete mechanism for explaining the origin of the image of the environment and perception as direct, not a mere abstraction about a loop of simply putting the body in action relationship. You need more than that. Gibson's notion of the body being directly specific to the environment only gains its needed coherence within this framework. So as in Gibson, when we place Bergson around Gibson, the brain is not generating, it is not creating an image. There are no representations in the brain. There's no little coffee cup in the brain. It's not projecting an image out there. The image is not emerging, to use the concept of emergence, magically from neural processes. The image is a specification, and I should have I've noted before, an optimal specification or an optimal percept because of the probabilities involved, the uncertainties involved, of a subset of the field, of a source within the holographic field. Or the brain-supported wave is specific to this Gibsonian term that none of our four players will ever understand, a source in the field. The wave is specific to a source in the field, and the coffee cup is right where it says it is within the external field. It is not within the brain. So Dr. Barrett, unfortunately, has a clouded, abstract, and vague understanding of direct perception and the role and the origin and nature of the image of the external world. It has to be placed within Bergson to make any sense. But this has its ill effects as soon as the discussion moves to cognition and memory. Barrett notes that Gibson does not deny imagination or memory images or fantasy or dreaming, as we started out with the first slide with the little cat dreaming about the mouse that got torpedoed. But then she immediately takes us to the idea that this non-denial of the existence of memory images or dreaming or dreams doesn't really matter anyhow. Why? Because, she says, we should, quote, remember that mental representations are theoretical constructs that we use to try to better understand certain aspects of our own and other animals' lives. So these constructs include memory images, apparently even dreaming. So notice, the images are gone. They're just constructs. They're just mental constructs, imaginary constructs. If you are vague as to what the perceptual image is, you will definitely be so about the memory image. And that's what's going on here. This mere theoretical construct stance is taken to its ultimate in chapter 11. So Barrett approvingly discusses an experimental robotic mouse. So without any memory storage, the mouse learns to negotiate a T-maze correctly to find the reward, namely the hamburger there on the left side. It uses its connectionist network. It's a connectionist mouse, a neural network mouse, and a few cues in the environment, such as a red wall on the one side to the right, and a stick leaning in the corner at the T. So here in the robot mouse, we have no storehouse of memories, no experiences, no images whatsoever, no need of memory images. Similarly, she approved approves Mark Rowlands' view, who we'll talk about later. He says, when we see a dog whimpering beside a road, and we're told the dog was nearly run over 6 months previously, we mistakenly attribute a memory experience to the dog. This notion should only be considered a convenient construct to make sense of his whimpering behavior. In other words, there's no image of the car nearly running over the dog, no memory image of that experience whatsoever. That's merely a convenient construct that explains his, I guess, Pavlovian conditioning. That's probably the true model here. So the dog, too, in Louise's conception, is just the robotic mouse. Thus, she argues, due to our fondness for the storage metaphor of memory, we aren't used to thinking about memory or remembering as mere theoretical props to explain what we and other animals do. That is, the non-memory experiencing robotic mouse is the true model. Now, this sounds very sophisticated, but it flies in the face of our experience. In fact, that's why it sounds sophisticated, because it flies in the face of our experience. We clearly experience the image or memory of, say, our wedding or our chickens. But shades of Daniel Dennett, which in his mind we're talking about conscious experience itself, we're supposed to deny this memory image of the wedding, declaring it as some form of illusion, as Dennett virtually has us try to deny our experience of even being in the wedding and seeing our wife as some form of illusion. And we're supposed to call it a mere theoretical construct to help us explain what? Well, why? To help us explain the experience of remembering with its images. In other words, while we are experiencing the image of the event, we are simultaneously supposed to be telling ourselves that this is a mere construct and that we are not experiencing it. I mean, this is the dilemma that we get into when we stick to this anti-representationalist view, our misunderstanding of Gibson and direct perception, and the ultimate denial of all memory images or retention of experience and experiences as images. This contortion stems from the Gibsonian's failure to set Gibson and his direct perception within the metaphysic he was using implicitly and which Bergson was stating explicitly. Gibson was really using an implicit metaphysic of Bergson, the temporal metaphysic. Remembering Bergson trashed the classic metaphysic, the spatial metaphysic. One can find this sprinkled in Gibson's books. For example, this little quote here, the idea that space is perceived, whereas time is remembered, lurks at the back of our thinking. But these abstractions borrowed from physics, namely the classic metaphysic which physics works in, are not appropriate for psychology. Adjacent order and successive order are better abstractions, and these are not found separate. So one has to think about this thing, this little concept for a second, this quote. But time remembered, space perceived. Again, notice how I've been stressing the fact that you have to explain the perception of time extended events. You're not just seeing a spatial instant, you're seeing a time extended event. The fish being pulled up from the water, the canoe flowing down the river, the butterfly flying by. So this is an index of the metaphysic that Gibson was implicitly working in. So Gibson ridiculed the storehouse concept, the idea of storing experience inside the brain. Truly, he did not think it was possible given his understanding of perception. I don't believe he thought perception occurred within the brain in the first place. Therefore, there's nothing to be stored. But this does not mean that experiences cannot be retrieved, because the brain is embedded in an indivisible or non-differentiable flow of time, or equivalently, embedded with the indivisible, non-differentiable dynamic transformation of the surrounding matter field. Therefore, the brain is embedded in a 4D field, a field which it can access. The brain is always specific to a past portion of this indivisible flow at a certain scale of time. As noted many times, a buzzing fly as opposed to a heron-like fly, or at even a smaller scale, a shivering crystalline ensemble of electrons, or an electron cloud. This flow is not a series of instants, discrete instants, where each just past instant falls away into non-existent. That's all part of the metaphysic in which Gibson has to be embedded. It is the indivisibility of this motion of the field that constitutes the primary memory, as it were, which allows the specification of the fly or the butterfly as a motion, as a time-extended experience. And we've talked, particularly in parts 2 and 4, of the extreme difficulty of trying to explain the perception of time-extended events via short-term memory storage models. So the fly is perceived right where it says it is in the external field, and directly. The experience then as a reconstructive wave is not within the brain, nor generated by it, and thus, as I noted already, it cannot be stored there in the first place. This is why the memory cannot be stored, but it's also why it can be retrieved. Yes, there is no storehouse in the brain, but the specified experience as part of this indivisible flow is always available to be retrieved by the brain, acting again as a reconstructive wave. The experience is not passed into non-existence. Via the operation of redintegration, which we discussed heavily in part 4, and which relies precisely on Gibson's invariance, or what I term the invariant structure of events, the brain is modulated to retrieve this experience. This is the missing but symmetric piece to direct perception, namely direct memory. That is, it's missing in the current Gibsonian framework of thought, as we're reviewing here. So past images are very real. They are not mere constructs. All this is the source of our supposedly unsophisticated, deep intuition of representations in thought and memory. By all this, I'm saying what we're talking about is a new metaphysic, overthrowing the classic metaphysic, dealing with the temporal metaphysic of Bergson, with an indivisible or non-differentiable flow of time, and a metaphysic that we saw is quite consonant with quantum physics, and the whole notion of the universe as a holographic field and the brain as a reconstructive wave. This is quite a move, and it makes an interesting question then. Which side is unsophisticated, the image side or the non-image side? So the failure to come to grips with the metaphysic in which Gibson is properly embedded is vitiating Gibson when it comes to extending him into memory and cognition and making a clear statement of what direct perception is, and therefore what the brain is. And further, it makes Gibson of little threat to the AI folks and their concept of achieving an imminent singularity, where robots equal human intelligence, pass human intelligence, and then conquer the human race. So let us move now to Anthony Chemero, his book Radical Embodied Cognitive Science. Chemero's thesis, in considering Gibson's direct perception again, again, effectively removes representations in perception. Via other arguments, some of which involve considerations of doing analogy without representations, he also argues for the removal of representations or lack of explanatory need for them in cognition. Now, I might stop here because I've done several things on analogy we saw, particularly in part 7. And one is going to start wondering how one possibly does analogy without representations. But moving on. On direct perception, Chemero slides over the fact that he has no actual theory of the origin of the image of the external world, just like Barrett, though he thinks he does. His argument pretty much comes down to this. He simply rejects the claim that the mind is a computer, which is nice, but then says, your science is about explaining experience. So you have to explain experience, where the meaningfulness of the experiences via those affordances is inseparable from, say, our seeing. So one has to think about this for a second. Remember those affordances. The affordances are inherently or intrinsically related to the possibility of action. I'm seeing a surface that simultaneously to me is walk-onable. I'm seeing a cup that is simultaneously graspable, and some coffee medium in it that's simultaneously stirrable. So the perception is intrinsically, inescapably meaningful simultaneously. It's inseparable from meaning. Now, somehow that's supposed to explain why that experience is an image. To me, this doesn't explain how I got an image of the external world out of the neural flows or flipping digits of a computer, which out of that is an image of the matter field, which also looks nothing like our experience. I hope you can see that. I mean, just saying meaningfulness is the magic is highly questionable. He also argues that embodied science doesn't need an account of qualia, the qualia of the perceived world. Remember the qualia being the brownish of the coffee or the creamish, the aromas are wafting. But this is true, that you don't need an account of qualia only if you can actually explain the origin of the qualitative image, the image of that coffee cup. And I would add, only if you have significantly altered our model of space, time, and matter, as opposed to the current classical or spatial metaphysic. As I've shown in the classic metaphysic, all quality has been stripped. We're talking a field of points, a continuum of points, mathematical points, that is stripped of all quality. You have to have a different metaphysic. You have to be moving into Bergson's temporal metaphysic, where you have indeed a qualitative field. So unless you're significantly and explicitly addressing a different metaphysic, saying you don't need a kind of qualia is rather without a whole lot of impact. Again, like Gibson, who argued that invariants in the optic array to which the brain is resonating allow the brain to be specific to the external environment, there is no explication of how the specific to actually results in an image. We saw we need Bergson's holographic reconstructive wave the holographic model to make that specific to meaningful. On the cognition side, Chemero's elimination of representations struggles again against the fundamental intuition, namely our obvious use of representations in thought. I can clearly imagine the construction of a new chicken coop, a nice Taj Mahal there for my chickens. But again, when one is virtually a non-source of or theory of the perceptual image, one will tend to deny the memory image, as Chemero is doing. And as Louise Barrett did, as we saw, it's just a construct. In fact, then one has not much of a theory of memory. I mean, you're going to start struggling. Some of this bleeds into contortion, such as on the Turvey-Shaw-Mace view. These are Turvey and Shaw and Mace being three key Gibsonian ecological exponents. Either babies do not perceive their mothers, or let's say do not perceive their mothers as mothers, because information for direct perception is unavailable. That is to say, I can see the fact that one's mother, being there as your mother, is not clearly simply available from direct perception, or as that is as a specification process, or they do not perceive them directly. And some rather strange somersaults to resolve this. But to me, I surely can see my mother as my mother because of memory. In fact, this is just a very bad neglect of the problem of explicit memory that I discussed extensively in part 5. The member of explicit memory being the ability that takes a couple years in Piagetian discussion and description of child development to be able to explicitly or consciously place an event as an event in one's past that one has experienced and simultaneously see the present event as reflective of that past event. That takes a while to develop. It's a fundamental and profound problem that I discussed, that one has to explain how this happens. But in this literature, apparently the problem of explicit memory doesn't even exist, which is kind of sad. So I'm moving to Mark Rowlands, The New Science of Mind, the extended mind, from extended mind to embodied phenomenology. So this is where extended mind, where the mind is conceived not to necessarily end at the brain, but extend into the environment, is espoused. And we have Mark over there with he happens to have written a nice book called The Philosopher and the Wolf, I believe. So I think that's a wolf. So a key component of Rowlands' framework is, quote, action on external structures, that is the environment, that transforms the information they contain from merely present to available. And he arrives at a position he terms amalgamated, that is, he looks at lots of positions in our many E's that we're dealing with here. He comes up with an amalgamated position which combines the embodied and the extended. And in this effort, he reviews the visual theories and work of Mars, O'Regan and Noé. We'll see Noé's shortly, Vygotsky, and Gibson. Now, Gibson's concept of the optic array, which I've never discussed, Rowlands notes, qualifies as the external structure of information par excellence. So let me describe the optic array very quickly. The optic array, as Gibson described it, can be looked at as a set of four-sided pyramids. For example, if you take the table and the four yellow rays coming from each corner of the pyramid there, each corner of the table, they make a pyramid that ends right at the eye there. the whole floor, the four corners of the floor that the table on make a pyramid, the little blue lines. And of course we could have any number of other little pyramids, which would have been too difficult and messy to draw. I could have a little square cup there to make it easy on top of the table that would also have its own little pyramid projecting to that point. So that point is called a station point, and each point can be conceived as holding the information from a set of projected light pyramids from the environment. So all the light pyramids project to that point. So each station point holds the info or the information for the whole scene. Kind of a holographic conception. I've never quite pushed through this, but it's there tantalizingly. And the optic array is the set of all station points, or the ordered set of all possible station points that that eye can sample. As you watch that, as that eye moves, again, we're a little better at dynamics here, that eye would, if that eye moved forward, one could imagine all those four-sided pyramids moving forwards and backwards as well. So that's the optic array. And Gibson's emphasis on the organism's action to transform this structure, so the eye hopefully moving because the body is moving, as that eye moves forward and backwards, it transforms the structure, thus isolating invariance. So the square structure of the table pops out as the eye moves back and forth, and therefore making this information available. And this emphasis on organism's action also fits perfectly for Dr. Rowlands. So the extended mind thesis that Rowlands defends is that at least some mental processes extend into the organism's environment, in that they are composed of actions performed on the world around the organism. So this therefore extends the notion of cognition beyond the brain, and that the whole body is or can be involved. Now this is a very limited notion of extended mind. Notice, it's nothing like we saw in Bergson. And as we'll talk about shortly later, just to review very quickly, but notice we're just extending some mental processes, whatever that means, into the organism's environment, because notice we're kind of getting a strange mesh of mental into the physical here, the environment, meshed with mental processes. Now, Rowland states in his book that even this limited extension is considered extremely problematic in his academic circles, and I respect his attempt to be conservative here because of this, but that's what's going on. So in this general conception, Rowlands reserves a role for the standard notions of representations current in cognitive science. In this, he differs explicitly from the view that Gibson denies as a construct in his view of the brain. So that this extended mind thesis that Rowlands might have arrived at would indeed be radical had he not ignored several major questions. The first is the problem of qualia, which he only obliquely approaches in his examination of Thomas Nagel, a famous article on What Is It Like to Be a Bat, which early discussion of qualia. And he does not come to grips with Chalmers and his statement of the problem at all. As noted, this problem, the problem of qualia, as I've argued in this series, is way more general. That Chalmers really is misleading us and with his emphasis on qualia, because truth, the problem is indeed the problem of the origin of the image of the external world. It happens to be a qualitative image, but nevertheless, you've got to explain the image in the first place. How does this image arise or get generated, or in general, is it accounted for? Well, we don't come to grips with that in this book. And if you're still holding, as Rowlands does, that the brain somehow employs representations to do this image thing, then you're back to what I call the coding problem that the concept of representations involves. Remember, 3 dots can stand for an S in the Morse code, or 3 tomatoes, or just a stove. One's got to know the domain to which to map the code, the 3 dots. Is it to letters? Is it to vegetables? Is it to kitchen equipment? To what? But the brain then, to use a code, in effect would have to already know what the world looks like. That is, it has to know the domain to use its representational code, for the neurochemical code cannot look anything like the external world. So I don't quite understand how Rowlands thinks Gibson can possibly be using representations in perception. And if to solve this, you're relying surreptitiously on the external structure of the field, say the optic array, then at what scale of time are you conceiving this structure or array or field to exist? As I've noted before, you have the buzzing fly of normal scale, a fly flapping his wings like a heron, a fly as an ensemble of atoms. As what? I'm dubbing this the scale fallacy, because we see this, we're going to see this again in no way. If the external field is indeed holographic, as one could also construe the optic array, a massive interference pattern, then it is unimageable at any scale of time. You cannot just assume the environment is a nice external structure that the brain uses, as though somehow the image of the external world as we know it already exists. It does not. Yet this is what is going on in Rowlands, and as we shall see in no way. Further, the external structure is not static, it is dynamically transforming, with buzzing flies and falling leaves, flapping winged herons, rotating cubes. So this is interesting because one does not need action from the body to, quote, make the structure change, unquote. There's plenty of change without the body acting. So admittedly, in the virtual action concept, even the perception standing stock still of seeing the rotating cube is nevertheless a function of action capability of the body. But I just find it interesting in this literature that we really are kind of ignoring the dynamic transformations. But nevertheless, you now open up another set of problems, for you now need a theory of the basic memory that allows the brain to specify, or for us to perceive, these transforming events as extended events over time. The leaf gradually falling, the heron flowing its wings up and down. Again, this is a major problem. It is a problem hidden under the notion of temporal consciousness, a whole subject in philosophy, but that's equally a problem of qualia. The way the leaves fall, the way the heron flaps its wings, the way the cube rotates or wobbles or whatever, the buzzing fly, that's all qualia as well in time. In fact, this has a greater primacy than the problem of qualia per se, for all perceived qualia extend over time. But this is just a dimension of problem that's utterly ignored. So this is where, in my humble opinion, Rowlands goes wrong in holding that Gibson is compatible with representational models. Representational models can deal with none of this. They can't deal with time. They can't deal with the coding problem. So anyhow, Gibson was well aware of the problem of the origin of the external image of the world, and further the difficulty with invariance defined only over time, like only over flow fields, or edges here in our rotating cube, which is a set of flow fields, where the edges are simply very ephemeral junctures at discontinuities of these flows as the cube rotates. No static representations can capture this. No symbolic manipulation or connectionist architecture, as I think Rowlands fails to see. An invariant defined over time cannot exist as a bit traveling along the nerves. This is why Gibson went to the notion that the brain is resonating, a time-extended process to these invariants. So the brain is resonating to these invariants, and the invariants exist only over this time-extended resonance, and that this resonance is specific to the environment, as our reconstructive wave is specific to the environment. The specific to has been the problem. For how does the specific to actually explain the origin of the image of the external environment and at a certain scale of time? So this brings us back again to the greatest philosopher of the extended mind, apparently unknown, despite Rowlands' attention to Heidegger, to Husserl, to Sartre, and many others. Bergson, as usual, is apparently non-existent, or hiding in his holographic field. But Bergson has noted, using the essence of holography, fills in the missing piece of Gibson. But Bergson's model is indeed extended. Why? Because in his model, the relation and the difference between subject and object is not in terms of time, or not in terms of space, but of time. Remember, the body and the external environmental field are one field, one continuous field. And the differentiation between subject and object in this field is in terms of imposing increasingly larger scales of time. From electron cloud flies to flies stationary to flies flapping their wings like herons to buzzing flies of normal scale. In this, the brain is seen as an entirely different form of device, as we saw, with a critical, real, concrete dynamics like that of an AC motor that is far from achievable by the connectionist, robotic, or computer models. So the neglect of Bergson in this embodied, and active, extended literature, even if only to consider and reject his vision for legitimate reasons, is just indeed unfortunate. It could truly give them an insight of what extended actually means and why, and what action, and especially as affordances in terms of virtual action, actually means and why. So, to Elva Noé, out of our heads. Noé sets out with great energy to convince us that consciousness is not something that happens inside us. It's something we do or make. In fact, it is something we do actively in our dynamic interaction with the world around us. Like grab coffee cups, pour them down throats. In fact, this explains why it has proved so difficult, he says, to create an explanation of the neural basis for consciousness, because we have to bring in this dynamic interaction. In this, he works on dismantling the view that it is the brain that produces images of our environment, that the brain being the sole author of what is commonly thought a grand illusion, which O'Regan and Noé made famous. But I'm not going to go into that too much. In other words, Noé is trying to put a hurt on that notion that there's any such thing as the image of a coffee cup inside the brain, or the brain is generating that in any way. But His prime weakness is that in this main thesis, the character of our experience, visual or auditory or kinesthetic, he argues, is not a function of some intrinsic character of the sensory stimulation. That is, of the specific kinds of neurons stimulated. That is, visual neurons or auditory neurons or kinesthetic neurons. Rather, it is the way in which the stimulation varies as a function of movement in relation to the environment. As I move around the table transforms in perspective in a lawful way, the way an object in vision, not hearing, should. So the way is arguing that the transformations of the visual world are specific to the visual world and transform specifically to the visual world, and this is what makes vision as opposed to audition or as opposed to kinesthetics. Implication 1, connect up your neural net or robot such that it responds lawfully to these transformations of the environment, of the table, and you have vision of the external world. Note there's nothing happening in the brain or the neural net in this conception, obviously, that looks like the external world, the kitchen table, the coffee cup, the spoon stirring. Yet somehow we're getting vision out of this. We're getting the image of the coffee cup. Implication 2, we just need to be in active relation to this external world. And miraculously, we get an image of it, correlated implication. One sees pretty much the same theme in all the expositors of Gibson, all that we've just seen. You just need to be in action relationship with the world, and we explain the origin of the image. Direct perception is now explained. But again, the first question which begs to be asked, why is this not a specification for a seeing robot? This is precisely, for example, what Kieferstein in Journal of Consciousness Studies in 2007 argued for strenuously. All we have to do is put the robot in active relationship with the environment, and voila, we get the image of the external world. The robot sees the coffee cup. And there's scores of others that hold this. I simply doubt there is an answer against this. Propose this in a way. Why is this not a specification for a robot, a vision-capable robot? So in fact, this thesis cries for some mechanism, some physical principle which explains this. Why, given this action relationship to the environment, is there now an image of the external world? And as we saw, this mechanism is the fact that the action relationship is the principle that selects out of the holographic field the image, the subset of information that's going to be specified via the reconstructive wave. That's the mechanism. And again, this image is at a scale of time imposed by the brain's underlying dynamics. The fly in the way's environment could be the buzzing bee in the normal scale, again, the heron-like, or the ensemble of whirling particles. See, Noé just assumes that the environment, he can just use the environment, again, to explain the image. The environment out there is a nice external structure to be sampled via action, and by that we get an image, except the environment doesn't necessarily look like any of what we normally see, anything of what we normally see, buzzing flies or whatever. Again, the selection principle for a subset of the massive holographic information is the relevance to the body's action. And again, Bergson, deeply reflective of Noé's relation to action, or Gibson's affordance concept, sees perception as virtual action. But in this context, that's the only way you're going to get an image out of action. So in the holographic reconstructive wave model of Bergson, there is within the brain no representation of the external world, no image being produced by the brain, and we have a concrete mechanism for explaining the origin of the image, not a mere abstraction about an action relationship with the environment. Noé's notion of the proper relation of the external world to action, or Gibson's notion of the body being directly specific to the environment, can only gain its needed coherence within some such framework. To make Bergson's model coherent, one needs at least this: a model of time and motion different from that of the current classic metaphysic of space and time. B, a different concept of the relationship of mind to time, namely the subject-object principle I noted. C, a different notion of memory, where experience is not stored in the brain but is yet available, due again to the indivisible motion of the field, the four-dimensional nature of the field. D, consideration of possible scales of time and perception. All subjects to which Noé gives virtually no consideration. With these, we could indeed understand why Noé's specification per se could not produce a seeing robot. So his arrow goes and he's blind. So all in all, this active relationship with the world, conception, struggles with these crying to be answered gaps. It would just be so much more powerful would these theorists pay attention to a thinker that was way ahead of them in 1896. So down the road, I'm still looking at uploading consciousness as a subject, and deep learning versus Bergson. Perhaps even this notion of temporal consciousness, which is a philosophical subject that is amazingly unknowledgeable about Bergson. Perhaps even whole brain emulation, which sort of fits in with uploading consciousness. So we shall see. Next time, I'll be tackling this question of storing experience in the brain. How is it done? Can it be done? We're looking at the various theories of hippocampal function, various theories of amnesia, where supposedly memories are destroyed in the brain, given the dogma that they're stored in the brain. Consolidation theory, how memories are fixed, how they're consolidated from short-term memory, from short-term areas to long-term areas, if that's true. Connectionist storage models on this very subject. So we'll be looking at how this is compatible with Bergson or not. Meanwhile, remembering that there truly is still, despite the announcements of advancements, just like the announcements of advancements continuously coming about creating consciousness in robots, we still don't know how memory is actually stored. And curiously enough, this subject is the effective inverse of the uploading problem, because if we haven't quite figured out how the brain experiences or stores experience in the first place, it's going to be interesting how we upload that experience to a computer. So we'll give it a try. Till then, signing off.